Right now, gravity is the only reason you're still alive. It keeps your blood moving. It holds your lungs in place. It keeps the atmosphere from flying into space. But what if, for exactly 1 hour, gravity doubled? Not forever. Not permanently. Just 60 minutes. You'd think that's not enough time to change anything. You'd be wrong. In 60 minutes, gravity at double strength would kill millions, reshape coastlines, and permanently alter the human body in ways that can never be reversed. And here's the part nobody talks about. Some people would actually survive, but not the ones you'd expect. You interact with gravity every single second of your life. When you stand up too fast and feel dizzy, that's gravity. When your back hurts after sitting all day, that's gravity slowly compressing your spine. When water flows downhill, gravity, we don't think about it because it never changes. It's the one constant in your entire life. The surface gravity of Earth is exactly 9.8 meters per second squared. That number hasn't changed in 4 billion years. But physicists have asked, what if it did? Even briefly, the results are not what you'd imagine. Because it's not just about things falling faster. It's about every single system in your body, on this planet and in the ocean reacting at the exact same time. And the reaction begins in the first 3 seconds. The moment gravity doubles, your body weighs twice as much. If you weigh 160 pounds, you are now 320 pounds, instantly, with no warning. Your legs don't break immediately, but your knees buckle. Your spine compresses faster than it ever has in your life. The discs between your vertebrae flatten under pressure they were never designed to handle. You fall to the ground whether you want to or not. Standing up becomes almost impossible for most people. Your muscles weren't built for this. Even professional athletes would struggle to stay upright. But the real danger isn't falling. It's your heart. Your heart pumps blood upward against gravity every single moment. Double gravity means your heart now has to work twice as hard to push blood from your legs to your brain. For a healthy 25-year-old, that's exhausting but survivable. For anyone over 60 with even minor heart issues, it's a cardiac event within minutes. Across the world, hospitals would be overwhelmed before the first 15 minutes are over. But what nobody expected, the people who survive best aren't the strongest. They're the shortest. Less height means less distance for the heart to pump blood vertically. Children and shorter adults have a measurable advantage. Tall people are at significantly higher risk of blacking out in the first 5 minutes. But what happens outside is far worse than what's happening to your body. Every structure on Earth was designed for one specific gravity, not two. Bridges weren't engineered for double load. Neither were buildings, highways, or power line towers. They were built with safety margins. But those margins don't cover 100% extra weight on every single component simultaneously. Within the first 10 minutes, structures start failing. Not all of them. But the ones already under stress, old bridges, tall skyscrapers in windy conditions, aging dams, begin to buckle. The collapse of one major dam in a populated area would release enough water to flood an entire region in minutes. Now multiply that by every aging dam on the planet. But the most terrifying effect isn't on land. The oceans react instantly. Water is heavy. A cubic meter of seawater weighs about 1,025 kilograms under normal gravity. Under double gravity, tidal forces don't just double. They interact with the moon's gravitational pull in a way that creates waves unlike anything in recorded history. Every coastline on Earth experiences a surge, not a gradual tide. A sudden, violent push of water inland. Low-lying coastal cities, think Miami, Amsterdam, Tokyo's Bay Area, would be underwater within 20 minutes. Not from a tsunami, from simple physics. But what nobody predicted is what happens to the atmosphere. Air has weight. We forget that because we can't feel it, but air is a physical substance, and gravity holds it down. Under double gravity, the atmosphere compresses. The air pressure at sea level increases significantly. It becomes harder to breathe. Not impossible, but noticeably harder. Like breathing at altitude, but in reverse. Worse, the compression heats the air. Not by much, but enough to accelerate weather systems already in motion. Any hurricane or storm system active during that hour becomes more intense. The energy feeding it increases. Wind speeds climb. The storm that was a Category 3 becomes something else entirely before the hour is over. Aircraft in flight experience a sudden increase in effective weight. Most commercial planes can handle it, but helicopters, small aircraft, and drones fall out of the sky within minutes, as their rotors can no longer generate enough lift to counteract twice the gravitational pull. Satellites in low Earth orbit also shift. Their orbital paths were calculated for one gravity. Some of them descend slightly. Most recover when gravity returns. But not all. And this is where it gets truly strange. After 60 minutes, gravity returns to normal. And that transition is almost as dangerous as the doubling itself. Your compressed spine suddenly decompresses. Structures that were holding under pressure now experience the opposite stress. Anything that cracked during the hour can fail completely as the load releases. The ocean surges back. The water that pushed inland now pulls outward with equal force. Coastal zones experience a second wave, this one going the opposite direction. Your heart, which had been working at double intensity for an hour, is exhausted in a way it has never been before. Heart attacks in the hours following are statistically far more likely than during the event itself. Recovery takes weeks. For some systems, geological, biological, infrastructural, it takes years. But here's what's almost impossible to believe. The gravity on the surface of a neutron star, the collapsed core of a dead sun, is approximately 100 billion times stronger than Earth's. If you could stand on the surface of a neutron star, your body wouldn't just be crushed. It would be compressed into a layer thinner than an atom in a fraction of a millisecond. You wouldn't experience pain. You wouldn't have time to register anything. You would simply stop existing as a three-dimensional object. And neutron stars are real. There are estimated to be over 1 billion of them in our galaxy alone. We live in a universe where that is normal, and somehow, on this one small planet, gravity landed at exactly the right number to allow life to exist. One number, unchanged for 4 billion years. The most important constant you've never thought about. Gravity isn't just a force. It's the reason you're here. And the fact that it has never changed, not once, not even slightly, might be the most remarkable thing about the universe we live in. Now I want to know, if you had to choose 1 hour to live through a gravity double, would you rather be underground, underwater, or in the air? Tell me in the comments. If this made you think about something you've never considered before, hit like. It helps more people find this channel. And subscribe, because next week we're asking a question that's even harder to ignore than this one.